Hey guys, today we're going to be talking about the mole map, and I'm going to walk through the steps you could take to draw it on your own. Now, what exactly is the mole map? A mole map is a visual roadmap that shows you that every conversion has to go through the central moles. Now, in chemistry, reactions don't happen in grams, they happen in mole ratios. Think of the mole as chemistry's universal translator. The mole map just shows you how everything connects through it. Now let's move on to drawing it. So now that we got our handy dandy whiteboard here, we're going to walk through the steps of how to draw your own mole map. This can be extremely useful when taking an exam, when studying on your own, or any other time that you need to do conversions in chemistry. It's pretty much just a visual representation of how to get from point A to point B. So let's get right into it. First thing you're going to want to start with when drawing your own is moles of A. The second thing, not surprisingly, you're going to want to write down is your moles of B. From here, we're going to show and represent how these two connect. Draw a nice arrow connecting on both sides, and to get from mole A to mole B, you're going to use the mole ratio. Nice. This can also be represented as A over B, or yada yada, however you want to do that. Now the next thing we're going to talk about is the conversion of moles and grams. On the left hand side of your moles A and your moles B, you're going to draw another arrow going out. And you're going to start with writing grams. Now to go from moles to grams, what do you have to do? You have to multiply by the molar mass of the compound you're working with. So at the top, when we're converting to moles to grams, we're going to put times molar mass. Pretty straightforward. Now let's say we wanted to go the other way. We started with grams, or were given grams. How would we get to moles? Well, simply just the inverse. Instead of multiplying by your molar mass, you're going to divide by your molar mass. Very simple. Now we're going to repeat that for step B. Alright, now we're able to convert from moles A or moles B to grams of either or. And we can convert from moles of A to moles of B. Now you might have to use exactly what we've outlined thus far. In an example where you're given grams of A and you have to convert it to grams of B, you'll go through the process of dividing by its molar mass, finding moles A, using its stoichiometric coefficients to make the mole ratio, converting it to moles B, and then you might have to convert it back to grams of B. But we're going to go through some examples later on, so let's move on to the next part. Now let's move on to the right-hand side. On the right-hand side, we're going to be looking at things that are called entities. Entities can include things such as formula units, particles, molecules, anything of that sort. So to begin with, we're going to put in our entities of A. Excuse my poor handwriting. Now to get from moles of A to entities of A, we're going to use Avogadro's number. Specifically, from moles to entities, you're going to multiply by Avogadro's number. Now I'm sure you can already assume what we're going to do if we were trying to convert from entities back to moles. We will divide by Avogadro's number. Easy enough. And we're going to replicate that step again for moles of B. Now we have the whole roadmap if you wanted to convert from grams to entities, grams of A to entities of B, from entities of A to grams of B, or any of them in between. So this is a huge foundational piece when we talk about the mole map. But now we're going to get into some more specific areas that you're going to need conversions for. All right, now we're back here on the left-hand side of the board, or I guess the right-hand side of the board for you guys watching. But now we're going to talk about the next conversion, and that's going to be our molarity, our concentration. Our M equals moles over liters. So where we're going to place that is up here at the top. So let's start by drawing an arrow coming out of the top a little bit to the left. And that's going to be our molarity. Now, somewhere nice and snug you can fit in here our equation, whatever feels comfortable. So when we're converting from moles A to say molarity of A, we're going to use our M equals N over L. It's pretty straightforward, not much to it, but now this opens up a whole new world for us where we're able to move from, let's say, grams of B to its moles, using the ratio to go to the moles of A, and then we can find the molarity of A. And there's a million other ways you could go through this. You could start with entities of A to molarity. You could start with grams of A to molarity, entities of B to molarity. But this is just going to show how universal this roadmap really is, how useful it is to have this in front of you. So now that we have our molarity of A, we can replicate this on the bottom for our molarities of B. Now that we have our molarity conversion factors, we're going to be able to find concentrations. This is going to be super helpful in general chemistry. Now the next thing we're going to move on to is our gas law. We're going to put another arrow at the top and the bottom here to represent our conversion factor. For this conversion, we're going to be talking about PV equals nRT. And we can again replicate this on the bottom. For now, this is going to be our completed mole map. This is going to give you a great introduction to being able to move between conversions in general chemistry. At this point, we have a lot of knowledge of how to convert. We can go from our gas law to our moles B, back to another gas law. We can convert from our entities to our grams, from our entities to our molarity. If you go through these steps of drawing it out and start understanding the mole map, you're going to be able to convert through pretty much every problem you need to in chemistry. This is going to complete our mole map for now. Right now, we have a great introduction and foundational understanding of our conversions in general chemistry. We're going to be able to convert from our grams to our entities, from our molarity to entities, moles of A to our gas law of B. There's a lot of conversions here. But if you can use this mole map, you can find your way through conversion from the start to the end. Now we're going to move on to some examples. So now let's go through an example of how we're going to actually use the mole map in a real chemistry problem. First, our question reads, when 15 grams of aluminum reacts with excess oxygen, how many molecules of aluminum oxide are produced? Before we do anything else, let's first write out our mole map conversions that we're going to do. Let's draw a little journey for ourselves that we're going to take to solve this problem. So let's start with our grams of aluminum. Our grams of aluminum are going to go to its moles of aluminum. Our moles of aluminum are going to go to our moles of aluminum oxide. And our moles of aluminum oxide are going to go to our molecules of aluminum oxide. So now we have the exact path that we're going to take. All we need to do now is plug in what we're given from our problem into the mole map and get from A to B. So let's go ahead and do that. So now to begin, let's write our balanced equation. Al plus O2 yields Al to O3. Now we got to balance this real quick. 4 moles of aluminum, 3 moles of O2, yields 2 moles of aluminum oxide. So from here, we can start our actual arithmetic. Let's start with our grams of Al. .0 grams of aluminum. Now we know by looking at our mole map, to convert from grams to its moles, we're going to have to divide it by its molar mass. Now we know that this arithmetic is going to give us our moles of our aluminum. So instead of solving for each individual part, I'm going to write this all in one big equation. So now we've converted from grams to moles. Now we're going to have to go from moles of aluminum to moles of aluminum oxide. To do this, if you look at your mole map, you're going to see that you have to use the coefficients. You have to use your mole ratio. So what we want is going to go on top, and what we're getting rid of it goes on bottom in regards to our coefficients. So we want our moles of aluminum oxide. Looking at its coefficients, we know that's 2. And we're going to divide that by our aluminum to cancel it out. So now if we solve this, first we found our moles of our aluminum, and now we found our moles of our aluminum oxide. If you did this whole arithmetic, 15 divided by 26.98 times 2 divided by 4, you're going to have your moles of Al2O3, your aluminum oxide. Now there's one last step we need to do in our mole roadmap. We have our moles of aluminum oxide. We have to convert to molecules. Now look back at your mole map, and you're going to find, to do that, you have to multiply it by Avogadro's number. I'm going to spell molecules like that just for sake of saving room. Just a little bit of shorthand. Now we have grams. We have grams to moles of aluminum to moles of aluminum oxide. And then once we have moles of aluminum oxide, we convert to molecules. So let's plug this into our calculators. So now when we go ahead and solve this problem on our calculators, we're going to find that we get 1.67 times 10 to the 23rd molecules. And that's going to be molecules of our aluminum oxide. This just goes to show how simple it really is when you follow the mole map. All you have to do is take what you're started with, look at the mole map, plug in what you need to find, and you have one beautiful equation which does that. You can also do this in steps, whatever works easiest for you. Now in this example, we're going to be talking about molarity and converting from moles to molarity. So our question reads, if 0.500 moles of NaOH react completely, what is the molarity of HCl required if it has a volume of 0.25 liters? Now, we're given the balanced reaction already. HCl plus NaOH yields NaCl plus H2O. Now, before we do anything or any arithmetic, we're going to write down our mole map road that we're going to take to find this answer. So first things first, we're given 0.500 moles of NaOH. So we're going to start there. That's going to be our moles of A. Our moles of A are then going to have to convert, if you look at your mole maps, to moles of B. From moles of B, we can directly find molarity of B. Remember, we're trying to find the molarity of the hydrochloric acid. We're given NaOH, so this is going to have to represent our A, and HCl is going to have to represent our B. So we convert from our moles of A to our moles of B to our molarity of HCl, of B. I'm just going to represent that by a capital big M. Now let's hop right into the problem. We know that we're given 0.500 moles of NaOH. So let's begin by writing that. Now our first step again is to convert from our moles of NaOH to our moles of hydrochloric acid. Now we're given our balanced equation already, and we can see here that for every 1 mole of NaOH consumed, we also use 1 mole of hydrochloric acid. So this means we're going to have a 1-to-1 ratio regarding its coefficients. And we're going to write what we want on top. So let's write 1 HCl. And on the bottom, we're going to write 1 NaOH. Now, using this equation, we've successfully converted from moles of NaOH, our moles of A, to our moles of B, our HCl. Now, let's not try and fit this all into one problem, just for sake of conceptual reasoning. So let's first solve this. Well, it seems pretty easy. 0.500 moles of NaOH times 1 over 1 is just 0.500 moles of HCl. That was pretty simple. Now we can move on to our molarity of HCl. So now that we have our moles of HCl, we can simply just use our conversion to convert to molarity of HCl. Now we know that the formula for molarity is molarity equals moles per liter. And fortunately, we're already given the volume in liters, which makes our job very easy. So let's just write this out. Molarity equals, in our case, 0.500 moles of HCl per 0.25 liters of our solution. After solving, you're going to find that we get simply 2.00 molar HCl. And when you're working through the arithmetic, don't forget about your significant figures. Here, we have 3. Thanks for watching, guys. I hope you took away some information from this video that was useful. Now, I would suggest go practice your mole map. You're going to use this all the time in chemistry, and it's going to be useful at every level. So thanks so much for watching, guys. I hope you enjoyed.